Welcome to Ask and Learn.
Okay, for this problem, we'll use the ratio test to first just figure out where we get convergence. So limit as n goes to infinity of an plus 1 over an. And by an, we mean this whole chunk here, including the x values. So this is x to the 2 times n plus 1 over n plus 1 ln of n plus 1 squared. So that's just our an plus 1 term. We're dividing by an, which is multiplying by the reciprocal of an. So now we're multiplying by n times natural log of n squared, and we're dividing by x to the 2n. So x to the 2 times n plus 1 is the same thing as x to the 2n multiplied by x squared. So x to the 2n will cancel out with this x to the 2n. And we'll just have x squared there. And then here we have an n, here we have an n plus 1. So we'll group those terms together. And then here, this is an exponent of 2, this is an exponent of 2. So we'll also lump these terms together. As n goes to infinity, natural log of n divided by natural log of n plus 1 is going to go to 1. You can see that by applying L'Hopital's rule. And as n goes to infinity, n over n plus 1 is also going to go to 1. So this is just going to be absolute value of x squared. And we want for that to be less than 1. Okay, but x squared is already going to be something that's non-negative. So x squared, the only real condition here is that x squared is less than 1. Okay, and this means that x is going to be between minus 1 and 1. So we'd get that by taking the square root of both sides, square root, and then doing the plus minus, and you'd get that x is between minus square root of 1 and positive square root of 1, which is just minus 1 and 1. Okay, so our interval of convergence is somewhere from minus 1 to 1. At this point, we don't know whether or not we include minus 1 and whether or not we include 1. The length of this interval is going to be 2, though, which means that the radius of convergence is 2 divided by 2, which is 1. So 1 is our radius of convergence. To figure out the interval of convergence, we need to know what happens when we plug in minus 1 into here and what happens when we plug in 1 into here. Okay, but minus 1 to the 2n is just going to be 1 because the exponent is going to be even, and 1 to any power is going to be 1. So we're going to get the same case when x is equal to minus 1. That'll be the same thing as when x is equal to 1. So there's really only one case we need to check here. Okay, so when x to the 2n gets replaced with 1, we need to ask ourselves what's happening. So then we'd have 1 over n times natural log of n squared. And here we can use the integral test to figure out whether or not we get convergence. Okay, so figure out whether or not this integral is convergent or not. Okay, so we'll do a change of variables here. So we'll do u equals natural log of n, which means that du is 1 over n dn. So whenever we see a 1 over n dn in this equation, we'll replace that by du. Okay, so if n is equal to 2, then u is equal to natural log of 2. When n is equal to infinity, u is equal to natural log of infinity, which is still infinity. Here we have a 1 over n dn, so we'll replace that by du. And then here we have natural log of n, but natural log of n is just u. So here we just have 1 over u squared. 1 over u squared is just u to the minus 2. So if you write it like that, it might be more clear how you evaluate this. We just do the power rule for integrals. So this is going to turn out to be minus 1 over u evaluated from natural log of 2 up to infinity. Okay, and we like to think about this as a limit. So I'll write limit as, we'll use m here, as m goes to infinity minus 1 over u from natural log of 2 to m. So that's limit as m goes to infinity minus 1 over m minus 1 over natural log of 2. This term is going to go to 0. Here we have negative, negative, so that's going to turn out to be something positive. But the important part here is that this is something that's finite. So the integral is going to converge. So by the integral test, we get that the sum that we were considering is also going to converge. Okay, so both of these endpoints are going to be included. So our interval of convergence, we include -1 and we include 1.